Okay, looking at example 5, you hopefully recognize this. We saw the exact same picture for the most part in lesson 24. Difference though, in lesson 24 we had some equal angles marked. This one doesn't have equal angles marked. Alright? But they do have parallel lines being marked, right? So what I want you to realize here, and we've already dealt with this idea several times this year, if we have parallel lines cut by a transversal, just by a little bit there we go, cut by a transversal, all the acute angles are equal to each other on that transversal, right? So looking at that picture, just the two parallel lines in that one transversal, this angle's acute and this angle's acute, that means those two angles are going to be equal to each other, right? Because of the parallel lines. Similarly, if I look at this transversal here, that's a little better. Parallel line, transversal, acute angle. These two acute angles are going to be equal to each other, but not equal to the green ones. Okay? Both of these acute angles are attached to this transversal. These acute angles are equal. These acute angles are attached to this transversal. Those acute angles are equal to each other. The third angle of each triangle is the top angle here. It's equal to itself. Looking at the small triangle, 5, 6, and 8 are the side measures, right? That contains that black angle on the top. And 9 and 6 plus x and y is the big triangle, also contains that black angle at the top, at the same angle. So basically it's the same picture we got in lesson 24, it's just different given information, but we get the same result. Angle, angle, angle similarity between the two triangles. The thing to be cautious of here is that we create proper proportions or proper scale factor ideas. What I want you to see here, again, let me just take these parallel lines out of the picture because they're getting in the way. Take these transversals out of the way too. Going back to the original problem. We've established the angles being equal now. What I need you to make sure that you always consider is that red angle is opposite this number 5. This red angle is opposite this side, which is 9. Be very careful that there will be two numbers there. One of the numbers is the actual number you use on the small triangle. The other measure here is allowed to create this together. 5 and 4 make 9. Similarly, over here, this green angle, 6 is opposite the green angle. This side, opposite the other green angle, is 6 plus x. It's not 6 times x, it's 6 plus x. X is important, but 6 plus x is more important. This black angle is opposite 8. It's also opposite y. Y is the entire side there, so that's already been taken care of. No modifications necessary on that one. So when you get these overlapping triangles, be careful that the three sides in the big triangle are constructed properly. Small plus small equals big. Small plus small equals big. Already big. All right, so you don't have to modify that bottom one. Okay, if I'm going to use proportions to do this, I always like my numerical one where I know all numbers to be in the middle. 5 and 9 is my relationship of sides where I know both numbers, right? So I'm going to put 5 over 9 in the middle. I chose to put the small triangle measure on top, which means when I go with 6 and 6 plus x, small goes on top, big goes on bottom. When I go with 8 and y, small goes on top, big goes on bottom. There's y. Use the proper letters here when you do it, please. There we go. All right. So again, just verifying this good proportion. 6, 5, 8 all come from the small triangle. 6 plus x, 9, y all come from the big triangle. 5 and 9 correspond. 6 and 6 plus x correspond. 8 and y correspond. When you're creating a good proportion, that's how you should determine that it's being done. If I first want to establish the value of x, that proportion is going to help me find x. 6 plus x is a binomial. Be careful that it's treated as such. So when I do this product, I get 5 times the quantity 6 plus x. When I do that product, I get 54. That gets me 30 plus 5x equals 54, which gives me 5x equals 24. Divide by 5, I get x equals 24/5. Also known as 4.8, 4 and 4/5. 24/5 is easier. It's the first place you get to. No calculator necessary. Alright? If I'm going for the other answer right here, this product, 5y, equals that product 72. Divide by 5, you get y equals 72/5. 14.4, if you're keeping score. 72/5 is easier, no calculator necessary. It's the first place you get to. All right, so that's how you do that. Overlapping triangles. Again, the parallel lines marked allow us to get some equal angles that get us to the similar triangles. Right now, when you see two triangles in any problem, it's going to be similar triangles every time. It's just a matter of figuring out which angles are equal. It's going to be your challenge.